Welcome to this explainer. Today, we are unlocking a completely hidden world of tech that, well, you're literally carrying around with you right this second. We're going to peek under the hood of the artificial intelligence hiding right there inside your smartphone. It is absolutely fascinating to demystify things like neural networks and LLMs to figure out how the apps we rely on every single day actually do their magic behind the scenes.
So let's kick things off with a quick question. How many times did you use AI today? It's super easy to write off artificial intelligence as this far-off sci-fi concept, right? Like robots taking over. But the truth is, if you interacted with practically any piece of modern tech today, you were already using multiple forms of AI, probably without even realizing it.
Think about it. When you wake up and just glance at your phone to unlock it with Face ID, bam, you're using a subset of AI called computer vision. When you ask Siri what the weather's going to be like, that relies heavily on natural language processing. If you order lunch on Zomato or grab an Uber, those magically accurate arrival times are driven by AI crunching complex traffic and time predictions. And of course, when you finally crash and open Netflix, YouTube, or Amazon, recommendation algorithms are instantly working overtime to suggest exactly what you should watch or buy next. You, my friend, are already a power user of highly complex AI. Here's our roadmap for today's explainer. First, everyday apps powered by AI. Second, machine learning, the engine. Third, 3 ways machines learn. Fourth, deep learning and neural networks. And finally, generative AI and LLMs. Let's get into it. Starting with Section 1, everyday apps powered by AI, recognizing the invisible tech in your pocket. At its very core, artificial intelligence is simply technology that allows computers to perform tasks that would normally require human intelligence. You know how good we humans are at spotting patterns? Like, if I tell you 1 equals 1, 2 equals 4, 3 equals 9, your brain instantly recognizes we're talking about squares, right? So you just know 4 is 16 and 5 is 25. AI basically allows machines to do exactly that. It also mimics human intelligence in speech recognition, understanding the actual context and meaning when you talk to Alexa or ChatGPT. Or take image analysis. The traffic department uses AI to automatically spot the numbers on a license plate and instantly issue a fine. It's doing a human's job, just in a fraction of a second. Moving on to Section 2, machine learning, the engine. Learning from data, not rules. Now, to understand how AI powers these apps, we have to talk about a massive paradigm shift. In traditional computer programming, a human writes the logic. You give the computer an input, it applies that human-written logic, and boom, you get an output. But machine learning, it flips this entirely on its head. With machine learning, algorithms learn from data instead of strict programming. You feed the machine both the input and the past outputs, and the machine actually figures out its own logic. This whole shift was made possible over the last couple of decades simply because the internet gave companies the massive amounts of data needed to feed these hungry algorithms. Let's use a bank loan application to break down exactly how this works in 2 steps. Step 1 is training. Imagine feeding a machine the past data of thousands of loan applicants, their credit scores, salaries, education levels, and you also tell the machine whether those past loans were ultimately accepted or rejected. By analyzing all of that, the machine builds a logic model. Then comes Step 2, inference. Now a brand new applicant walks into the bank. The machine uses that logic model it built during training to predict if this new person's loan should be approved or rejected. This exact 2-step process, training, then inference, is exactly how Gmail predicts if an email is spam, or how Swiggy knows when your dinner will arrive. All right, Section 3, 3 ways machines learn: supervised, unsupervised, and reinforcement. So there are 3 primary pillars of machine learning we need to look at. We've got supervised learning, which relies on labeled data, unsupervised learning, which tackles unlabeled data, and reinforcement learning, which works within an environment to maximize rewards. Let's break each of these down so you can really see how they apply to the ops sitting right there on your phone. First up is supervised learning. This happens when we train a model using data that is clearly labeled with the correct answers. Within this bucket, we're usually solving 2 types of problems: classification and regression. Classification is basically sorting data into predefined categories. A perfect everyday example is Gmail. Gmail is trained on millions of emails that are specifically labeled with features, like sketchy sender addresses or suspicious links, to classify brand new emails into 2 distinct buckets, spam or not spam. Regression, on the flip side, tries to predict a continuous numerical value. When you order from a food delivery app, the algorithm crunches the distance and past driver data to give you a numerical regression prediction, like your food will arrive in exactly 15 minutes. The second way machines learn is unsupervised learning. Here, the machine gets raw, unlabeled data and has to find the hidden patterns totally on its own by grouping related data into clusters. Imagine feeding an AI millions of raw online news articles. Without ever being told what they are, the AI will naturally cluster them by finding related keywords, creating neat little groups for sports, tech, or politics. Why does this matter? Well, it is incredibly useful for spotting anomalies. Because the AI knows exactly what a normal cluster looks like, it can instantly flag weird outliers. This is exactly how cybersecurity systems detect if your account suddenly logs in from 5 different cities in under a minute.
The third type is reinforcement learning. And honestly, this brilliantly illustrates how we can teach a machine through pure trial and error. Think of it kind of like training a puppy. You give it a treat when it sits, and you hold back the treat when it doesn't. In reinforcement learning, the AI model, which we call the agent, interacts with an environment. When it makes a good move, it earns a positive reward. When it makes a bad move, it gets a negative penalty. Its one and only goal is to maximize its total rewards over time. This is the exact method AI uses to learn how to play incredibly complex games like chess, or even simple ones like snakes and ladders. And it's a huge deal in the world of self-driving cars and robotics.
Next up, Section 4, Deep Learning and Neural Networks, the brain behind unstructured data. Okay, so normal machine learning is great at tabular, structured data. Think neat spreadsheets of house prices. But it really struggles with messy, unstructured data, like the millions of individual pixels in a YouTube video or all the subtle nuances in a WhatsApp voice note. Deep learning is what solves this. It's a subset of machine learning that uses artificial neural networks, which are heavily inspired by the actual neurons in the human brain. Instead of a human trying to program what an eye or a nose looks like in a photo, a neural network uses an input layer, multiple hidden layers, and an output layer to automatically extract all those useful features from completely unstructured data. But how in the world does this complex network actually learn anything? Well, it happens in 2 main steps. First is forward propagation, where the network takes the input data, calculates weighted sums across all its layers, and basically takes a guess. It makes a prediction. The second step is backward propagation. This is where it checks how wrong its guess was, its loss, and goes backward through the layers to adjust its internal weights. Think of a college grading system. If a professor makes midterms worth 40% and class tests worth 20%, they might notice students are just skipping class. To fix that mistake, they adjust the weights, right? They make class tests worth 30% and midterms 30% to boost attendance. Neural networks do this exact same trial and error adjustment, tweaking millions of mathematical weights until their predictions become razor sharp. This nonstop trial and error math is exactly how TikTok's algorithm figures out exactly what kind of videos will keep you scrolling for hours. Finally, we arrive at Section 5, Generative AI and LLMs. From predicting to creating. Up until this point, all the machine learning we've talked about was focused on predicting an outcome or classifying data. But generative AI, it represents a massive, earth-shattering paradigm shift. Traditional AI predicts, but generative AI actually creates. We're talking about generating entirely new text, brand new audio, hyper-realistic images, and even videos that have quite literally never existed before. The absolute powerhouse behind this text generation is the large language model, or LLM for short. These are massive neural networks. We're talking billions or sometimes even trillions of parameters, trained on just vast, vast amounts of text from the internet, books, articles, you name it. LLMs are built to solve natural language processing tasks. And what's really fascinating here is that modern LLMs use a specific architecture called transformers. Instead of reading a sentence word by word like older, clunkier models did, transformers look at the entire sequence of text all at once. They use a clever mechanism called attention to understand which words relate to each other, which gives the AI a truly profound understanding of the context and the actual meaning of human language. And this brings us right back full circle to the apps you might be using every single day. When you ask ChatGPT or Claude to help you draft an email, you are using one of those massive text-generating LLMs. When you play around with Midjourney or DALL-E, you are using Gen AI to create stunning images out of thin air. Developers are using GitHub Copilot for code generation. And insane tools like Sora are pushing the boundaries by generating full-blown, high-def videos from simple text prompts.
All these highly technical concepts we just went over, neural networks, transformers, parameter adjustments, these are the invisible forces radically changing daily workflows across the entire globe. So, as we wrap up this explainer, I really want to leave you with this final thought. The next time you seamlessly unlock your phone with your face, or let Netflix pick your Friday night movie, or ask ChatGPT to help you brainstorm, take a second to think about the millions of data points, those hidden layers of artificial neurons, and the nonstop mathematical adjustments firing off in mere milliseconds behind the scenes. Now that you actually know how the magic works, how will you look at the apps in your pocket differently? Keep exploring and keep learning.